Hello friends. So, welcome to lecture series on multivariable calculus. So, we were discussing about differentiability, that what do we mean by differentiability of two variable or more than two variable functions. We have seen that for differentiability, existence of first order partial derivative at that point is necessary condition, and to prove that whether a function is differentiable at a point or not, we have to show either delta z is equals to dz plus fx at x naught y naught, okay, at fx this is this thing, and epsilon 1 delta x plus epsilon 2 delta y. So, epsilon 1 epsilon 2 should tend to 0 as delta x delta y tend to 0 comma 0. So, this is the first way out by which we can show that function is differentiable at a point x naught y naught, and the second way out is you simply take limit delta rho tending to 0 delta z minus dz upon delta rho should equal to 0. So, where what is dz? dz is fx at x naught y naught into delta x plus fy at x naught y naught into delta y, and delta rho is under root delta x square plus delta y square. So, we can prove the differentiability of a function f x y by any one of the definition, either by this definition, either write this condition and try to show that epsilon 1 epsilon 2 tend to 0 as delta x delta y tend to 0 0, or try to find out this value and try to show that this limit is tending to 0. Okay. Now, we will discuss one more problem based on this. Show that this function is continuous, possess its partial derivative at 0 comma 0, but not differentiable at 0 comma 0. So, how can we solve this problem? Let us see. So, fxy is equals to x cube minus y cube upon x square plus y square, xy not equal to 0 comma 0 and 0 when xy is equals to 0 0. So, first part is continuity. So, for continuity at 0 comma 0, what we have to show? We have to show that limit xy tending to 0 0 x cube minus y cube upon x square plus y square should be equals to f at 0 0, which is 0, f at 0 0 is 0. So, this to prove for continuity. Okay. Now, how can we show that this limit exists and is equal to 0? So, in order to prove that this limit exists and equal to 0, we have to use delta epsilon definition. Okay. So, let epsilon greater than 0 be given. Now, take mod x cube minus y cube upon x square plus y square minus 0, which is equals to mod of x cube minus y cube upon x square plus y square, which is less than equals to mod of x cube upon x square plus y square plus mod of y cube upon x square plus y square, okay, which is equal to mod of x into x square upon x square plus y square plus mod of y into y square upon x square plus y square. Because y square and x square are non-negative quantities, can be taken out from the modulus. Now, these quantities, now x square upon x square plus y square is always less than equal to 1. Similarly, y square upon x square plus y square is always less than equals to 1. Okay. So, these quantities are always less than equal to 1. So, we can take that less than equals to mod x into 1 plus mod y into 1. So, if we take mod x less than delta, so it is less than, delta plus delta, that is 2 delta. So, if we choose two delta is equals to epsilon, then mod of x cube minus y cube upon x square plus y square minus 0 will be less than epsilon whenever 0 less than mod x less than delta and 0 less than mod y less than delta. So, in this way we have shown that this function is continuous at 0 comma 0. Okay. Next we have to show that the first order partial derivative exists at 0 comma 0. So, f(x) at 0 comma 0, it will be by the definition limit h tending to 0 f of 0 plus h minus f(0) upon h. Now, this will be equals to limit h tending to 0. Now, you replace x by h and y by 0 in this definition. So, it will be h cube minus 0 upon h square plus 0 and it is minus 0 upon h because f(0) is 0. So, this will be limit h tending to 0 h cube upon h cube and this is 1. Okay. Now, you compute fy at 0 comma 0, it is limit h tending to 0 f of 0 comma 0 plus h minus f(0) upon h. This is limit h tending to 0 f(0) comma h. Now, you replace x by 0 and y by h, it is 0 minus h cube upon 0 plus h square minus 0 upon h. So, this will be limit h tending to 0 minus h cube upon h cube which is minus 1. So, we have shown that its first order partial derivative at 0 comma 0 exists and the values of f(x) is 1 and fy is minus 1 at 0 comma 0. Now, the third part is function is not differentiable at 0 comma 0. It is continuous at 0 comma 0. First order partial derivative exists at that point, but function is not differentiable at that point. Okay. How can we show that function is not differentiable? Now, to show that a function is not differentiable at 0 comma 0, we can use any one of the definition. So, try to find out this limit. Now, limit delta rho tending to 0 delta z minus dz upon delta rho. First, what is delta z? Delta z is f of 0 plus delta z delta x 0 plus delta y minus f(0) which is delta x cube minus delta y cube upon delta x square plus delta y square. This value is 0. Now, what is dz? Dz is f(x) at 0 0 into delta x plus fy at 0 0 into delta y which is delta x minus delta y, because this is 1 and this is minus 1. Okay. So, what will be delta z minus dz? So, this will be delta x cube minus delta y cube upon delta x square plus delta y square minus delta x plus delta y and whole divided by delta rho. Now, we can convert this limit as limit delta x delta y tending to 0 0, because when delta rho tending to 0 and delta rho is under root delta x square plus delta y square, when delta rho tend to 0, then delta x delta y will definitely tending to 0 0 and this will be delta x cube minus delta y cube minus delta x cube plus delta y into delta x square, okay, then minus delta x into delta y square and plus delta y cube and whole divided by. Now, this expression is delta x square plus delta y square, the under root of delta x square plus delta y square and this term. So, this will be delta x square plus delta y square whole raised to power 3 by 2. Now, this term is cancelled with this term is cancelled with this term. So, we are having this expression as is equals to limit delta x delta y tending to 0 0. This is delta x square into delta y minus delta x into delta y square upon delta x square plus delta y square whole raised to power 3 by 2. Now, function is not differentiable at that point, this we have to prove. So, what we have to prove basically? We have to prove that this limit does not exist, because if this is limit exists and is equal to 0, then function will be differentiable at that point. Okay. So, anyhow we have to show that this is path dependent. So, you can easily see that the power of the numerator is 3, okay, and the power of denominator is also 3. So, if we take a linear function, so it will comes out to be dependent on m, the parameter m. So, move along delta y is equals to m delta x. If you move along this path, then it is delta x into 0, it is delta x square into m delta x minus delta x into m square delta x square upon delta x square plus m square delta x square whole raised to power 3 by 2, and this will be equals to limit delta x tending to 0 delta x cube m minus m square upon it is delta x cube come out and it is 1 plus m square whole raised to power 3 by 2. So, this will cancel out and this will be m minus m square upon 1 plus m square whole raised to power 3 by 2. So, this limit depends on m and hence this limit does not exist, and this limit does not exist means function is not differentiable at 0 comma 0. So, that is how we can show that function is not differentiable. Okay. If it is not differentiable, that means we have to show that this limit does not exist. Okay. Now, let us see some more properties of differentiability. Okay. Now, let a point x naught y naught be changed to x naught plus delta x and y naught plus delta y. We want to predict the approximate value of change in the value of f. Okay. X is changing, x y is changing from x naught y naught to x naught plus delta x, y naught plus delta y. So, what will be the approximate change in the value of the function, that we want to find out? How can we find that? Suppose f is differentiable function and its first order partial derivative at x naught y naught are known. The change in the value of the function is given by this expression. We already know this thing. Now, if we move from a point x naught y naught to a point x naught plus dx and y naught plus dy nearby, the nearby point, the resulting differential of f is given by this thing. So, what is the resulting differential of f? Resulting differential of f is df is equals to fx x naught y naught dx plus fy at x naught y naught to dy, which we are also calling as total differential of f. Okay. Now, let us discuss few examples based on this. Okay. Basically, we are finding the approximate change in the value of f by this expression. Okay. This is the first order derivative at x naught y naught, fy, fx and fy, and they are change the value of x and change the value of y. So, let us discuss few examples. The first problem, near the point 1 comma 2 is fxy, which is equal to x square minus xy plus y square minus 3 more sensitive to changes in x or to change in y? This we have to find out. Is it more sensitive in changing in x or changing in y? Okay. And what can we say about this at point 2 comma 1? So, what is the function? Function here is x square minus xy plus y square minus 3. Okay. First find fx. Fx is 2x minus y, and fx at point is 1 comma 2. At 1 comma 2 it is 2 minus 2, which is 0. Now, fy is minus x plus 2y. So, what is fy at 1 comma 2? It is minus 1 plus 4, that is 3. So, what will be df? df will be fx at x naught y naught, fx at 1 comma 2 which is 0 into dx plus 3 into dy which is equal to 3 dy. So, this means the change in if we change the value of x, the change the value of there will be no change in the value of f, because there is no term in the term of dx here. Okay. If we change the value of x, there will be no change in the value of f at a point 1 comma 2. But if we change the value of y, okay, the value of function will change by 3 units. Suppose we change y by 1 unit, then the change in the value of f will be 3 units. Okay. So, that means it is more sensitive to a change in the variable y, not of x. It remains unaffected in the change in the value of x. Okay. Now, if we can check the same sensitivity at a point say 2 comma 1. So, how can we check that? Now, at 2 comma 1 we have to find out. So, at 2 comma 1 it is equals to 4 minus 1 which is 3, and at 2 comma 1 it is minus 2 plus 1 minus 2 plus 2 which is 0. So, what will be df? Df will be simply 3 dx because this is 0. So, what we can say now? We can say that the change in the value of the function will remains unaffected if we change in the y nearby. Nearby means near the point 2 comma 1. Okay. Now, if we change the value of x by 1 unit, the value of function will change by 3 units. That means at this point it is more sensitive to the change in the value of x and remains unaffected to a change in the value of y. Okay. Now, the second problem, using differentials find the approximate value of this term. So, what is the term? Basically it is under root of 298 whole square plus 401 whole square. So, we have to find out the approximate value of this x. Okay. So, how can you find this? Let us define function as under root x square plus y square, under root x square plus y square. Okay. Take x as 300 and y as 400. Take dx as minus 2 and dy as 1. Okay. Because this minus 2 will be 298 and this plus this will be 401. The next point, basically we start from this point, this is x naught y naught, basically this is x naught y naught, okay, and x naught plus dx will be this point and y naught plus dx will be this point. Okay. So, what will be the approximate change in the function value? That will be given by fx at x naught y naught into dx plus fy at x naught y naught into dy. What is fx? F of this, fx of this, it is x upon under root x square plus y square, and fx at 300 400 will be. So, at this point 300 and 400, so when you substitute x as 300, it is square is 9 16 25 5 which is 500. So, it will be 3 upon 5. And what will be fy at 300 400? That will be 400 upon 500, that is 4 upon 5. So, what will be df? Df will be 3 upon 5 into dx is minus 2 plus fy is 4 upon 5 and dy is 1. So, that will be simply minus 6 plus 4 upon 5, that is minus 2 by 5, that will be minus 0.4. The approximate change the value of the function is minus 0.4. So, what will be the functional value? What will be the functional value? So, df will be f at 298 and 401 minus f at 300 and 400. because f at x naught plus delta x, y naught plus delta y, and f minus f at x naught y naught. So, what is function value of this? So, f at 298 and 401 will be df plus f at 300 and 400, and df is minus 0.4 as we have already computed, and this is simply 500. You substitute it here. So, this will be 49.6. So, the approximate value of this capital X will be 499.6. Now, the third problem, a certain function z is equals to fxy has values f at 2, 3 is 5, fx is 3 and fy is this. Find the approximate value of this. So, again we can easily find out using the same concept. So, what are things given to us? F at 2, 3, fx at 2, 3 and fy at 2, 3. So, what is f at 2, 3 is 5, 3, 7. Okay. Now, we have to find out f at 1.98 and 3.01. So, we can take dx as minus 0.02, okay, because 2 when you add with this you get 1.98, and dy as 0.01. Okay. Now, df, the approximate change the value of the function will be fx at 2, 3 dx plus fy at 2, 3 into dy. So, this will be 3 into minus 0.02 plus 7 into 0.01, that will be minus 0.06 plus 0.07, that is 0.01. Okay. And the change the value of the function is given by f at 1.98 3.01 minus f at 2, 3. So, this implies f at 1.98 3.01 will be equals to df plus f at 2, 3, and df is 0.01 plus f at 2, 3 is 5. So, this will be 5, that means this value is 5.01. So, the approximate value of the function at this point is 5.01. Okay. So, this is one type of problem which can be solved using differentials. Now, we can also find absolute, relative and percentage change in the value of the function. How we can find out? So, if we move from a point x naught y naught to a point nearby, then we can describe the change in the value of the function f x y in 3 ways. First is absolute change, which is estimate is df, true is delta f. Relative change, where true is delta f divided by f at x naught y naught, and estimate is df upon f at x naught y naught. The percentage change means you would simply multiply the relative change by 100. Okay. So, how can we solve some problems based on this? Let us see. Suppose the variables r and h change from the initial values r naught h naught, which is 1, 5 by the amount dr equals to 0.03 and dh equal to minus 0.1. Then estimate the resulting absolute, relative and percentage changes in the value of the function v equal to pi r square h. So, v is pi r square h. The initial point r naught h naught is 1, 5. dr is the change in the value of r is 0.03 and dh is minus 0.1. Okay. Now, we have to find the relative and absolute change in the value of v. How can you find that? First, we find dv. dv will be, now here v is a function of r and h. Okay. Instead of x and y, we are having r and h. So, how can we define dr here? dr will be vr at r naught h naught comma dr plus dr, sorry, into dr, and Vh at x naught y naught r naught h naught into dh, because here instead of x and y we are having r and h as independent variables. So, we have to differentiate partial respect to r and h only, and function is v. Okay. So, what is Vr? So, first we find Vr. Vr will be 2 pi Rh, and Vr at 1 comma 5, which is r naught h naught, is 2 pi into 1 into 5, which is 10 pi. Again Vh at 1 comma 5 will be, what is Vh? Vh will be pi r square. So, pi into r square, r is 1, so that is pi. So, this will be 10 pi into dr is 0.03 plus Vh is pi into this is minus 0.1. You take pi common, so this is 0.3 minus 0.1, which is 0.2, so it is 0.2 pi. Okay. So, what will be relative change? Relative will be dV upon V, that is 0.2 pi upon the value of the V at r naught h naught, value of the function at x naught y naught. Okay. So, that will be pi r square into h. So, that will be simply pi cancel out, it is 0.2 upon 5, that is 0.04. Okay. And the percentage error will be, percentage change will be this into 100, that is 0.04 into 100, that is 4%. So, that is how we can find out absolute, relative and percentage change in the value of the function. Now, next problem, find the percentage error in the computed area of an ellipse when an error of 2% is made in increasing the major and minor axis. Okay. So, what is area of the ellipse? Is pi AB. Okay. Now, what will be the change in the area? dA will be AA dA plus AB dB. I mean here instead of x and y we are having a and b. So, we have to differentiate partially with respect to a and b only. Okay. So, here we get pi b into dA plus pi a into dB. Now, dA upon a will be equals to pi b dA plus pi a dB upon pi ab, and that will be dA upon a plus dB upon b. So, the percentage change will be dA upon a into 100 will be equals to dA upon a into 100 plus dB upon b into 100. So, that will be 2 plus 2, that is 4%. So, that is how we can find out the corresponding percentage error in the value of the area of the ellipse. Now, there are also some more problems based on this. Let us solve one more problem. The power consumed in the electric resistor is given by P is equals to E square upon R. Okay. In watts, if E equal to 80 volt and R equals to 5 ohms, how much power consumption will change if E is increased by 3 volt and R is decreased by 0.1 ohm? So, that we can find out. So, here E naught is 80 volt and R naught is 5 ohms. Okay. DE is, it is increased by 3 volt, that is plus 3 volt, and DR is decreased by 0.1 ohms, that is minus 0.1 ohm, and we have to find the corresponding change in the power consumption. Okay. So, how can we find now? So, here P is given by this expression. So, what will be the relative change in the value of P? that will be, now P is a function of E and R. So, it will be PE into DE plus PR into DR, okay, because here independent variables are E and R. So, when you differentiate here with respect to R, so it will be 2E upon R into DE plus it is E square upon minus R square into DR. Now, what is E? Because we have to find this value at this values at E naught V, E naught R naught, these values at E naught R naught. Okay. Now, what is E naught? E naught is 80. So, it is 2 into 80 upon it is 5, DE is 3 minus this minus E square is 80 into 80 upon R square is 5 into 5 into and DR is minus 0.1. So, we can simplify this and we can find out the corresponding change in the power consumption. Okay. Similarly, we can solve the next problem also, which is given in electrical circuit. Okay. Now the first problem of the next slide is, say y equal to uv, where u and v are independent variables. If u is measured with 2% error and v is measured with 3% error, what is the percentage change in the value of y? It is very simple problem. So, here y is equals to uv. So, dy will be equals to basically yu into du plus yv into dv, that is v du plus u dv, and what is dy upon y? That will be du upon u plus dv upon v. So, dy upon y into 100, that is a percentage change in the value of y, will be the percentage change in the value of u plus percentage in the value of v, that is 2 plus 3, that is 5%, because it is given to us that the 2% is the percentage change in the value of u and percentage change in the value of v is 3%, but at corresponding change in the value of y will be 5%. So, that is how we can solve problems of this type. So, thank you very much.